for the nice introduction. So very welcome to the very last session presentation of this conference, in which I will talk about the wastewater safety planning approach we take in our Pavitra Ganga project, which is an EU-India joint research and innovation project that aims to unlock wastewater treatment, water use, and resource recovery opportunities for urban and peri-urban areas in India. And I'm pretty sure you might have heard about the project during this conference because we're very well represented this time, I would say. So I'm very happy to present today on behalf of the whole wastewater safety planning team in our project group. Especially like to thank and also acknowledge Folake Balbalola, an IET graduate who complemented her master research in Kanpur on wastewater safety planning. So a substantial part of the results, or the preliminary results, I will present are basically from her master research. So in my presentation, or in our presentation, I will first talk about the wastewater safety planning approach we follow in the project, and we'll also quickly address the scopes of different risk and impact assessment approaches. Then we will continue with the learnings we have so far from the wastewater safety planning activities in Kanpur, which includes basically the system description of Kanpur's wastewater treatment and water reuse system, and also some preliminary results on risk and impact assessments for farmers. So, as mentioned, our approach for sanitation safety planning, or wastewater safety planning, how we call it in our project, bases on the 6 steps outlined by the WHO's sanitation safety planning manual. So the very first aim of the wastewater safety planning is for us that together with stakeholders we'd like to assess and prioritize and also mitigate exposure risks at the 2 Pavitra Ganga test sites. So you have 1 test site in Kanpur and 1 test site in Delhi. And this includes the identification of disease pathways and also the affected people, such as, for example, wastewater treatment plant workers, farmers, but also the communities. And then we want to estimate the risk associated to the reuse or handling of this untreated or treated wastewater. As a second aim, and since our let's say improvement plans or control measures we to address the risks mainly foresee technological measures, we will also come up with so-called technology-based wastewater safety plans that will also include operation and maintenance requirements and occupational safety and health provisions. So just to highlight a little bit the differences between our approach and the WHO's sanitation safety planning approach. So in the Pavitra Ganga project we have a stronger focus on technological risk management strategies rather than the behavioral measures that sanitation safety planning focuses a lot on. Then since there was the pandemic, setting up this wastewater safety planning process with stakeholders has been extremely difficult. So this means that for now it has primarily been the Pavitra Ganga project members who guided the risk assessment activities in the area. And finally, we also found that among the case studies presented in the sanitation safety planning manual, very few have actually looked at situations where mixed wastewaters, so this means domestic and industrial wastewaters, have been supplied for irrigation. And this is actually the case in Kanpur, so we think we will see some interesting outcomes that might be also relevant and added to the WHO's case study portfolio. So now before we talk about Kanpur, I also would like to briefly touch upon risk and impact assessment methods, because we heard a lot about the different methods within these risk assessment sessions, and different methods have also been presented. And yeah, there are a range of health risk assessment methods and approaches available, from very simple ones to more detailed and detailed ones, and from rather expert-based assessments to more evidence-based assessments like the QMRA, for example. So one of the rather simple kind of risk assessments are these sanitary inspection forms. So sanitary inspections are typically based on standard forms, checklists to identify the most common issues that may lead to the introduction of hazards into a system. Then there are these kind of risk matrices. So those who have attended our workshop on Sunday on wastewater safety planning have actually applied such a risk matrix. So these risk matrices, they provide sort of a qualitative or semi-quantitative evaluation of the likelihood that basically hazardous event would occur and the severity or the consequence the hazard would have if it would happen. And based on the severity and the likelihood, basically a risk score is calculated. So this approach is rather expert-based, but can be also undertaken at different levels of detail. And it is stressed by the WHO that all health risk assessment approaches are valid. So their use is really context-specific and will depend on human resources available and also the type of the supply system. So in our Pavitra Ganga project, we apply on our semi-quantitative approach, and I will present some results or some learnings related to that now. Something else I wanted to stress is that for the risk assessment, we use sort of multiple sources of data and multiple approaches to analyze data so as to enhance, let's say, the credibility of our study. So we first looked at existing literature, highlighting potential health hazards within the area. Then we designed and conducted a questionnaire survey, also key informant interviews, and conducted also observational checklists. And finally, we looked at potential fecal contamination in the irrigation channels, for example, with an E. coli monitoring survey. So for the E. coli monitoring survey, we analyzed E. coli concentrations from different sampling points along the wastewater treatment and reuse systems. I will talk about that a little bit later. And we used standard plate counting methods, but also trialed this time Equagen's compartment bag tests that basically allow detection of E. coli in the field. So up to now, our study only focuses on microbial health risks, but of course, within this year, we will also have a focus, or we will also look at the chemical health risks related to wastewater and reuse in Kanpur. So now let us see how the wastewater treatment and reuse team in Kanpur looks like. So this is a really basic figure, but nevertheless, the study focuses on the wastewater treatment plant of Chachmao. It's a 130 MLD sewage treatment plant based on activated sludge process. The treated sewage from the activated sludge process is then basically mixed with the tannery effluent from a common effluent treatment plant. And so I think around 160 MLD of water is then discharged in a 4-kilometer irrigation channel to about 2,500 hectares of peri-urban farmland. And there are 40 villages located in the peri-urban areas, which basically have access to these irrigation channels. And with this system in mind, the questions we want to answer with our study are, so what are the health risks related to the wastewater treatment plant? What are the health risks for wastewater treatment plant workers in the existing systems? Then we are also interested in health risks for water users in the existing systems. And then we want to see whether if we would replace the existing system with sort of novel technologies that we look at in the Pavitra Ganga project, whether it has basically a health impact for the identified exposure groups. Since we very much, or we talked a lot about occupational health risks for wastewater treatment plant workers in the workshop. We will only talk now about health risks for the farmers. So for the village survey, we had a look. I mean, I said there are around 40 villages based in the peri-urban area of Kanpur, and together with a local NGO called Solidaridad and our project partners Aqua, we had a close look at 3 villages, and they sort of present a transect across the irrigation area. So we had the village Alaulapur, Kulgaon and Ladukeda, and we first conducted sort of village walks with community members to understand how they basically could get exposed to microbial contamination. So we did not only look at the irrigation channels, but we were also interested to understand their drinking water practices and sanitation practices, and we mapped these water sources. So we had a nice map of available hand pumps, for example. And then we had around 75 questionnaires conducted. We did, as I said, sanitary inspections with the household to understand their drinking water, sanitation and irrigation practices. Yeah, there are some impressions of these villages over here. I will like to first present the results of the E. coli measurements we did. So we had, as I said, we had sampling locations not only at the reuse sites, so not only in the irrigation channels and the fields, but we also sampled the treatment trains. So we had a sampling location at the preliminary treatment, then after the primary treatment, the effluent, activated sludge effluent. And since our pilots were not running by that time, so the study was conducted between July and August last year, we basically then sampled the effluents from our lab scale installation of the IPC membrane and constructed wetland plus. So these are basically the results of the plate counts. We see that there is almost no log removal from the activated sludge process. That's sampling point number 3 in the graph. So E. coli concentrations in secondary treated effluent are in the range of 10 to the power of 7. The lab scale installations of the IPC membranes, that's S4, and S5 is the constructed wetland plus, were between 10 to the power of 4 for the constructed wetlands and 10 to the power of 6 log reduction for the IPC membranes. In the irrigation channels, we found E. coli concentrations between 10 to the power of 5 to 6, and in the fields between 10 to the power of 4 to 5. So these E. coli concentrations, according to the WHO guidelines, do not meet the safety standards for labor-intensive irrigation, which is set at E. coli concentrations of 10 to the power of 3. Or in other words, there are health risks related to these water reuse practices. So what we've learned from the questionnaire-based survey and also the inspection checklist is that Alaulapur and Kulgaon, or in Alaulapur and Kulgaon, 60 to 70% of the farmers really use this water from the irrigation channels almost every day. Thus this practice seems quite frequent and presents a high exposure given the E. coli concentration seen in the slide before. We also found that open defecation rate in one of the villages was quite high, thus additional microbial hazards next to the wastewater reuse are likely to be introduced into our system. Finally, households do not treat drinking water before consumption, which can, if the drinking water is contaminated, also be a potential transmission route for microbial pathogens. So we used the data to come up with a really preliminary health risk assessment for farm workers. Once we've done that, we went back to the farmers and then we rediscussed and adapted also the risk assessment. So we identified high risks for microbial pathogens and also soil helminth infections, mosquito bites, and never can pronounce this, musculoskeletal problems related to farming activities. And let's say, I mean, this is now really hypothetical, but given the results we have from the lab scale Pavitra Ganga technologies, we expect, at least for the microbial risks, a considerable reduction of the risks identified. So we expect low risks after these novel technologies would have been identified. These novel technologies would have been implemented. But as I said, these are really preliminary results and assessments, and we really have to have a further look at this and explore it during the last year of the project. So to wrap up, we use a semi-quantitative health risk assessment approach to identify health risks along Kanpur's wastewater treatment and reuse scheme. We have found high microbial risks for farmers and communities. Within the existing systems, the measured log removals of our lab scale technologies would indicate safe use in agriculture. But as I also said, we really also have to have a holistic assessment of other exposure routes. So for example, we have to have a closer look at what's going on with the sanitation in these rural areas. So the study is still ongoing. Some of the next steps we have in mind is, of course, to measure the E. coli log removal data from the actual pilots. Then we also want to have a closer look into chemical pollutants and health risks in the area. We also plan for a restitution workshop with the villagers where we present them which risks we identified. And we also want to discuss potential control measures. And we might also look into more quantitative risk modelings to come up with sort of health impact potentials for the novel technologies. So that's the end of the presentation. So if you're interested in the project, please check out our project website, our social media channels, and yeah, there's a lot of material to be